of science teachers in Saudi Arabia was. The stage is yours.
Hello everyone. First of all, I'd like to thank the organizer. Let me introduce myself. I am Faris Alsaadi, a PhD candidate at the Department of Education in the University of York. I am also a lecturer at Taiba University in Saudi Arabia. Today I'm going to present my research, which is about an important topic, especially for those who are interested in inquiry-based learning and teacher change, as well as curriculum innovation. The title of my research is An Investigation of the Perception of Inquiry-Based Learning Amongst Science Teachers in Saudi Arabia. In 2008, the Ministry of Education in Saudi Arabia adopted a translation of an American series of science textbooks to be taught across all school levels. These textbooks were developed according to the National Research Council in the United States. The pedagogical framework of these textbooks is based on inquiry-based learning and student-centered approach. However, it appears that the Saudi science teachers did not implement an appropriate teaching method that could meet the demands of the new science textbooks. Also, it is not clearly understood how Saudi science teachers perceive and implement inquiry-based learning within classroom. Furthermore, no research has been found that addressed science teacher perception toward IBL within Saudi context. Therefore, this study investigated Saudi science teachers' perceptions, beliefs, and implementation of inquiry-based learning. This study sought to answer the following research questions. How do Saudi science teachers understand inquiry-based learning? What are Saudi science teachers' beliefs about inquiry-based learning? How do Saudi science teachers implement inquiry-based learning in the classroom? What are the Saudi science teachers' perceptions of the challenges that are faced in trying to successfully implement inquiry-based learning? A mixed methods design was adopted, and the data was collected from 3 different methods: classroom observation, interviews, and online questionnaire. Field notes were taken in the classroom observation and then analyzed by using the STAR instrument. I will talk about it in the coming slides. The type of the interview was semi-structured interviews. The interview data was analyzed by using thematic analysis. The online questionnaire contained 2 types of questions: close-ended questions and open-ended questions. The close-ended questions were analyzed by using descriptive statistics analysis, while the open-ended questions were analyzed by using thematic analysis. This study involved Saudi science teachers from 3 school levels: primary, middle, and high. 27 science teachers were observed and interviewed. 288 science teachers completed the online questionnaire. The qualitative findings of teachers' understandings of IBL showed that teachers had different understandings about IBL. However, the term researching was the most reported term. more than a quarter of participants who provided their own definition of IBL indicated researching when describing IBL. This finding indicates that most participants did not have well-structured knowledge about IBL. Rather, they used a very broad explanation, such as researching and discovering. On the other hand, some participants had narrow understandings about IBL, such as asking questions, posing questions and problem and doing experiments. This table shows the quantitative findings of teachers' understandings of IBL. These activities were taken from the definition of inquiry-based learning as suggested by the National Research Council 2000. Also, there were two of non-inquiry activities were added to find out whether teachers were able to distinguish between inquiry and non-inquiry activities. Teachers were asked to express their agreements to these activities as a part of inquiry-based learning or not. Most of participants agreed with the inquiry activities. However, many respondents mapped non-inquiry activities onto inquiry activities. Only 11% of the questionnaire sample were able to correctly recognize and distinguish all inquiry and non-inquiry activities. The findings of the interview and the online questionnaire show that the participants held a strong positive attitude toward inquiry-based learning as suggested by the Ministry of Education in Saudi Arabia. The interview findings showed that all teachers agreed that inquiry-based learning, as defined by the National Research Council, is important and effective in teaching science. The participants indicated a range of reasons that may justify their positive attitude toward inquiry-based learning. This table shows the main themes extracted from the interviews related to teachers' beliefs about inquiry-based learning. 10 teachers believe that inquiry-based learning enhances students' understanding, and 7 teachers believe that inquiry-based learning promotes self-directed learning. 4 teachers reported that inquiry-based learning develops students' ability and skills. 3 teachers reported that inquiry-based learning enhances psychological factors related to learning, such as motivation and interest. This table shows the questionnaire findings related to teachers' belief about inquiry-based learning. As can be seen from this table, most teachers agreed to these statements about the potential benefits of inquiry-based learning as suggested by the Ministry of Education in Saudi Arabia and the National Research Council. The average mean was 4.50, which indicates that Saudi science teachers held high positive attitude toward inquiry-based learning. The science teacher inquiry rubric was used to assess teachers' practice of inquiry-based learning in the classroom. The STAIR instrument was developed by Bodzin and Pira. The STAIR instrument has 6 categories and it is based upon the 5 essential features of classroom inquiry as suggested by the National Research Council. Each categories could be in a learner-centered direction or teacher-centered direction, or it is not observed at all. Here in this slide, the other three categories of the STIR instrument. This table shows the findings of teachers' implementation of inquiry-based learning. 45 science lessons were observed. As shown in the table, the most observed features of inquiry was teacher helps learners give priority to evidence. The second most observed features of inquiry was learner formulate conclusions and or explanation from evidence. The third most noted or observed features of inquiry in the classroom was learners communicate and justify their proposed explanation. The fourth most noted inquiry features in the classroom, learners are engaged by scientifically oriented questions, which was observed 19 times. As shown in this table, there were two features of inquiry that were rarely observed in the classroom, which were learners evaluate the explanation in the light of alternative explanation, and teacher engage learner in planning investigation. As shown here, when the inquiry features was noted in the classroom, it was in the teacher center direction. This figure shows the frequency of each feature of inquiry-based learning in the STIR instruments presented in the 45 observed lessons. As explained in the previous table, the most observed inquiry feature was teacher helps learner give priority to evidence, which was observed 31 times. And these two features of inquiry-based learning were rarely observed. As stated earlier, the direction of the observed inquiry features was very teacher-centered. The participants reported in the interviews and the online questionnaire 5 major challenges that prevent them from implementing inquiry-based learning, including lack of resources, large numbers of students in classes, heavy teaching load, students' lack of abilities, and heavy curriculum content. The findings of the present study revealed that science teachers showed limited understanding and practice of inquiry-based learning. However, they held a strong positive attitude towards inquiry-based learning. It is appear that the lag between beliefs and practices result from the influence of contextual factors such as lack of resources, large numbers of students in classes, and heavy teaching load. The findings of this study also suggest that there is a gap between policymakers and
Die
science
war doch eine
teachers
Woche,
in
oder?
Saudi Arabia.
Die Woche.
Teachers need more
Und
support
dann war sie
to
verpeilt
enhance
mit
their knowledge and
Karte
implementation
davor heben
of
oder auch nicht.
inquiry-based learning. Thank you very much for listening. If you have any questions, I'm happy to answer it.
Yes, thank you very much. I am sure there will be questions to your presentation, and I'd like to open the floor for everyone who's interested in getting in touch with you. So there are already questions coming up in the chat. So Janelle Johnson, for example, is asking, the gap you noted between policymakers and teachers is important. Have you found any strategies for informing policymakers? Would you like to answer to Janelle? You're still muted. You just have to click the blue button on the right-hand side.
Sorry.
It worked, right?
Yeah. Actually, the findings of the study will be sent to a copy of it to Ministry of Education in Saudi Arabia. So they will be informed about this gap. After I finish my thesis.
I am experiencing some noise by Bräuning right here. So, Bräuning, could you please switch off your microphone because you're...
Thank you so much for your positive feedback. And anyone if has any comments or any notes,
There's another question by T. Anderson. I have a very capable Saudi Arabian student at university currently who has told me about the school system there. One thing she highlighted is that she didn't have much experience of organic mechanisms being taught there. So I wonder if that could be incorporated into initiatives like this.
Not sure about the organic mechanisms, what exactly you mean by this phrase. But if you are if you're talking about gender issues, maybe the system is equally, the same system in Saudi Arabia teaching, the same curriculum in the male schools or female schools. Yeah, if you can just clarify what you mean by organic mechanism. Okay, right.
Yeah, all right. The confusion is because it is an area of chemistry, and they thought it was an relevant as you mentioned STIR, right?
Right. Yeah. Okay.
Yeah, I believe so. Yeah, you misspoke the acronym. Don't worry about it. Are there any more questions on topic? That seems not to be the case at the moment.
Okay.
So, thank you very much for this lively and very...
Thank you so much for this opportunity. Thank you so much.
Welcome. Yes. So let's move on to the, unfortunately, already the last presentation of this evening session.